Dear students, in our today's class, we are going to discuss about the things which we have discussed in our previous class. That is, open file in write only mode and open file in read only mode. Also, opening file in append mode. Come to the first point. That is opening file in read only mode. See, these are the modes. There are three modes under which we can open a file, and these are the modes. Two modes I have written. After this, I'll write one more. Read only. What will happen if you open a file in read only mode? Okay, file can be opened in three modes. The first is read only mode, and the next one is the write only mode, and the last one is append. Okay, if we open file in read only mode, then at that time what will happen? Come, we shall see now. When a file is opened in read only mode, when a file is opened in read only mode, the get pointer automatically set to very first byte. Think we are having some contents in the file. Okay, I think these are the contents. Think these things as contents. They are contents of a file, and this is a file. So, and each content of a file starts with 0, counts with 0. Very first byte. Then the get pointer is automatically set to the very first byte. That is, the get pointer will point to the first byte. The get pointer will point to the first byte. Which is the first byte? The first byte is the 0th byte. Okay, you know, everything in computer will always start with 0. So here, this is also the same thing. The very first byte means the 0th byte of the file. Okay, then what is the use of this? That is setting a put pointer to the first byte. What is the use of it? Come, we shall see. This helps to read the file contents from the beginning. Okay, when a file is opened in read only mode, at the time a get pointer automatically set to the first most byte, and this setting of a get pointer to the first most byte, that is the 0th byte, will help us to read the contents of the file from the beginning itself. Here in bracket, one thing is given: the bytes in a file is numbered starting with 0 or starting from 0. The bytes in a file are numbered starting from 0, as I have shown here. Hope you have understood the read only mode. Next, come to the write only mode. When a file is opened in write only mode, okay, here get pointer is there to read. Here for writing we have to use we will not use, but it will take the put pointer. See, the contents of the file are erased here. Okay, when a file is opened in write only mode, then contents of the file are erased if it exists. If some contents are present in the file, then those contents will get erased when we open the file in write only mode. At that time, what will happen? And the put pointer is set to the first byte of the file. See, this is a file. We have opened in write only mode, so contents are erased. At that time, the put pointer set to the first byte of the file. Here, first byte is there, so the put pointer will set to the first byte of the file, so that we can write data from the beginning, we can start data from the beginning. I will give one more example. If you open notepad or Microsoft Word in your laptop or computer, or either in your WhatsApp in your smartphone, if you open to message to someone, then what will happen? A cursor, a line, a black line will blink in the place of writing. It will begin at the starting of the file. This is the best example. Whenever you open to message to your friends, at the time in the place of writing, the cursor will blink at the starting point itself. This is called opening file in write-only mode. Hope you have understood the concept. So this is about read-only file and the write-only file. Come to the third type, that is opening file in write-only mode. Opening file in append mode. We have discussed about two things. One is opening file in read-only mode. The next one is opening file in write-only mode. And the third thing is opening file in append mode. What is meant by appending? I have already explained that appending means adding something to the end of the file is called appending. So come now, we shall see. In some situations, it would be necessary for us to add new data. Not only the data, but the text. Okay, data means either text or images, anything it may be. We can call it as data to the existing file. Already file is there, and we want to add some more data to that file. At that time, in this case, we have to open the file in append mode. If you want to add new data to the file, at that time we need to open that file in append mode. Okay. When a file is opened in a append mode, at that time the put pointer moves to the end of the file. The put pointer will move to the end of the file. Why? Here put pointer will move because we need to add something. We are not reading, we are editing the contents of the file. So that is called appending. So here the put pointer will move to the end of the file so that we can add or we can write new data from that location where put pointer is set. From that location we can able to add new data to the file. Now come to the next thing, that is the internal string pointers that point to the reading or writing locations within a string can be manipulated using the following member functions. We have discussed in our previous class four member functions. They are seekg, seekb, tellg, tellb. 4 member functions we have discussed. Among them, now we are going to discuss each member function individually. The first one here is seekg. What it will do? It will move the get pointer to the specified location. Okay, from the beginning of the file. Seekg will move the get pointer to the specified location from the beginning of the file. See here, you need to use small letters only. Don't use capital letter S. Okay, as I have written, in the same way you have to write. Okay, it will move the get pointer to the specified location from the beginning of a file. Okay, under CG there are two types. One is CG long within braces, then semicolon, within parentheses, then semicolon. Then CG offset comma seek dir. Seek dir closed in pair of parentheses and then semicolon. Among CG there are two types. Now we are going to discuss seek long and seek offset seek dir. Now come to seek long. The seek long moves the get pointer. Okay, get pointer. You need to remember where the get pointer comes and where the put pointer comes. That's the main thing. Okay. The seek long moves the get pointer to a specific location from the beginning of the file. Example, inf.seekg20. This means the seek pointer. Okay, will the seekg long it will point the location of the 0th byte from the 20th byte. Okay, if 20 bytes are there in a file, in that file it will point to the 0th byte. Okay, and next come to seek G offset and seek dir. The seek G offset seek dir has two arguments. That is, one is offset, the next one is seek dir. Seek offset and seek dir. What the offset will do? The offset indicates the number of bytes the get pointer is to be moved from seek dir position. There are two positions. From the seek dir position, how many number of pointers have to be moved? That indicates the offset. Okay, and next, the offset takes long data. It treats long data. Whereas seek dir means direction for seeking. Direction for seeking the offset position inside a file. Seek dir means direction for seeking the offset position inside a file. It takes one of the following three seek direction constants. After this, I will write the seek dir constants. Among those constants, seek dir will take any of the constants. Okay, hope you have understood the seek long and seek offset dir. Seek G long, seek G offset and seek dir. Now see, what the seek dir will do? Seek dir takes one of the following three seek direction constants. Which are the constants? The constants I have written. These constants are defined in iOS class. Any of these three constants. One is iOS co-preservation bed, iOS co-preservation CUR, iOS co-preservation and end. What this constant indicates? Offset specified from the beginning of a file. BEG means specified from the beginning of a file. Then CUR means offset specified from the current position of the get pointer. It is beginning of a file. Okay, here it is specified from the beginning of a file, but it specified from the current position of a get pointer, where the get pointer is there, shows the position of the get pointer. iOS and offset specified from the end of the file. This seek dir will get any of these three constants. Hope you have understood the concept. Now I am going to write the examples for seek G long and seek G offset, seek dir. Now come, we shall see the example for seek G offset, seek dir. Here inf.seek 0, iOS, then scope resolution bank. This will send, okay, the pointer to the 0th byte. Okay, and then inf.seek 20, iOS, scope resolution big. Then this will send the pointer to the 28th byte. And here we have taken, for same example, we have taken -20. This means this will move the pointer to 28th position in backward direction from 28th to 0, like this in backward direction. So these are the things regarding seek G long and seek G offset, seek dir. Now we are going to discuss about the next member function, that is seek P. So we shall see how seek P will work. Now come to seek P long. See, seek P first. It will move the pointer to the specified location. What seek P will do? It will move the pointer to the specified put pointer here. Seek G will move the get pointer, whereas seek P will move the put pointer to the specified location from the beginning of a file. Okay, and this there are two types. One is seek P long, the other one is seek B offset, then seek dir. Come to first seek B long. The seek B long moves the put pointer, okay, to a specified location from the beginning of a file. Same as this. See, move the put pointer to the specified location, moves the put pointer to a specified location from the beginning of the file, Understood? Okay. Then example INF dot seek B of 20. This is regarding seek B and seek B of long. As I have told many things under seek G, same as here in seek B, but here we will use the put pointer. Whereas in seek G we will use the get pointer. See, you need to remember seek G for here comes get pointer and seek B here it takes put pointer. How will you able to remember that seek G takes get pointer and seek B takes put pointer? Here G indicates get pointer and P indicates put pointer. Like this you have to remember. If you remember like this, then you can easily able to judge the pointers by writing, or else you will get confused and you may able to interchange the pointers. So best to remember like this: seek G get pointer, seek B, here B is the right pointer. Okay, and now I am going to write about the next type, that is seek B offset, seek dir. Now come to seek B offset, that is seek dir. As we have discussed in seek G, the same way here, but only put pointer here works. See, it has two arguments, offset and seek dir, as we have discussed in seek G. The offset indicates the number of bytes and put pointer here, not get pointer but put pointer. The put pointer is to be moved from the seek dir position. Same as seek G, here seek B. Only put pointer is used. And then the offset takes long data type, as we have discussed. And seek dir, that is direction for seeking the offset position inside a file, takes one of the following three seek direction constants. One of the three seek direction constants. And which are the constants? The constants defined under seek G offset seek dir. No need to write like this. This is I have written for your reference. We have to go here and search the constants. Okay, while writing you need to write all the three constants. Which are the constants? IOS scope resolution BEC, IOS scope resolution CUR, IOS scope resolution then end. All the three constants you have to write here. And now example INF.cp0 to IOS scope resolution BEC. It shows the position of 0 byte. Then here it will move to the position of 28 byte. Here it comes to the position of 28 byte from the end of the file to 20. Okay, hope you have understood the concept. So this is regarding seek B long and seek B offset, seek dir. Dear students, now come. We shall go to the next two member functions, that is tail G and tail B. Here no much definitions are there, only the uses of tail G, the use of tail B and their syntaxes. What tail G will do? The IF string class provides a member function by name tail G. The purpose of this function is to return the current position of the get pointer, where the get pointer is located. The tail G function will give the position of the get pointer. Okay, example, take int position. Position equals fin dot tail G, then tail G function semicolon. And the same way tail B. This is also come from IF string. Both are from IF string class. Okay, provides a member function by name tail B. The purpose of this function is to return the current position of the pointer. So return the current position of the put pointer. Tell G will return the current position of the get pointer. Here G indicates get pointer. P indicates put pointer. Tell P. Okay, the purpose of this function is to return, okay, the position of the put pointer. Same syntax here. In place of tell G, use tell P. That's in position equals a fin dot tell P function, then semicolon. This is about the four basic member functions of the file system. Opening a file, that is CP, CG, tell P and tell G. Now we have left with the last topic of your data file handling, that is basic operations on C++. Now come to the last topic of your chapter, data file handling, that is basic operations on binary file in C++. Basic operations on binary file in C++. There are 5 operations. One is searching, second one is appending data, the next one is inserting data in sorted files, then deleting a record, the last is modifying data. No expansion and no explanation about these 5 operations, but they are very much important for your examination point of view. Just remember this: searching, appending data, then inserting data in sorted files, then modifying data, then deleting a record. Okay, only remember these 5 types. Okay, this ends your data file handling. In our next class, we shall move to database concepts. As earlier, I have started with the database concepts only. Maybe you have remembered something about database concept, even though I will start the chapter with beginning itself. Okay, in the previous classes, in the offline classes, we have discussed many things regarding database concepts up to normalization. Okay, only half of the chapter has left. Before that, this pandemic corona has spread, so due to that we got so much of lockdown. Okay, so we shall see, we can continue in the next class from the beginning of the data structure itself, and this is an end of your data file handling chapter. Anything about the chapter, if you have not understood, ask me personally. Thank you.